All right, so welcome to today's online class from Toronto. So what we're going to be doing today is we're going to continue, or we're going to look at various research methods that we're going to be using throughout this course. You're going to be learning about them in the experiments you read, in the findings where you're learning about the principles of learning. So before we get to that, however, we're going to revisit learned helplessness one more time to see if we can apply the terms that we learned last class to an analysis of Seligman's work on learned helplessness. So as you recall, just one more quick recap. Martin Seligman, he studied the effects of prior learning on subsequent learning, and he had dogs as his subjects. And in part one, he split the dogs into three different groups. Group A received no shock, so they were in a room. There was a panel that they could press. The floor could be shocked, but Group A received no shock while they were in that room. Group B received escapable shock, meaning that when the floor began to be shocked, the dogs could press the panel to escape the shock that would turn off the shock. And Group C also received shock, but it was inescapable. So nothing that they could do, including pressing the panel, would turn off that shock. Importantly, remember that Group B and Group C received the same amount of shock, so they would be shocked at the same time and in different rooms, and Group C's room would turn off as soon as Group B pressed their panel. And then in part two, he took a look at how did this prior learning in part one affect subsequent learning in part two. And for this, he used a shuttle box where on one side of the room, there was a speaker and a floor that could be shocked. On the other side of the room, there was a speaker and a floor that could be shocked. In the middle, there was a hurdle that the dog could jump over. And the speaker would sound a tone. After a certain period, the floor would begin to be shocked. And then the dog could escape that shock by jumping over to the other side where the floor was not being shocked. And if the dog could learn the association between the tone and the shock, then the dog could go from escaping the shock while it was occurring to actually completely avoiding the shock, using the speaker as a signal that would then, the tone as a signal, so that they would then jump over to the other side and they wouldn't be shocked at all. So how did they learn in part two based on their experience in part one? Well, this was the interesting results that Seligman found, and what he found was Group A was able to learn the escape and avoidance response, so they were able to learn to jump over to the other side to avoid the shock. Group B was also able to learn to jump over to the other side to avoid the shock. However, Group C, who had inescapable shock in the first part, did not learn to jump over to escape the shock in part two. So even though they were fully capable of jumping that hurdle to escape the shock, their learning in part one impaired their learning in part two. So I asked you last time to think about how do the terms that we learned last class apply to this learned helplessness study. So in this experiment, we'll now just take up what are the independent and dependent variables. So if you haven't already, I invite you to pause the video at this point. Think about what are the independent and dependent variables for part one and part two. And then when you have your answer, write it down and then come back, press play, and we'll go to the answers. All right. So hopefully you've written down your answers. What are the independent and dependent variables for part one and part two? So for part one, the independent variable would be the shock and also the control. So one of the things that varied between the groups and was under the experimenter's control was the shock. So the experimenter chose that Group A would receive no shock and Group B and C would receive shock. So that was one of the independent variables, one of the conditions that systematically varied throughout the experiment and was under the experimenter's control. The other independent variable was the control that the dogs had. Now, this doesn't really apply to Group A because they didn't receive any shock, but Group B had control over the shock. They could press that panel to stop the shock. Group C did not have control. So that is another variable, another independent variable. And again, it's because the experimenter had control over that variable. The experimenter decided Group B was going to be able to control the shock. Group C was not going to be able to control that shock. And then the dependent variable in this case was the behavior that was measured, that was completely up to the subject, and that was the panel press, and that applied mostly to Group B. So the dependent variable was whether they would press the panel, how quickly they would press the panel. That was the thing that could vary. Some dogs might press it quickly, some dogs might not press it at all, but that was measured and allowed to vary freely. So the dogs were allowed to press the panel whenever they wanted, and the experimenter would simply measure that panel press. All right, in part 2, once again, there's an independent and dependent variable. The independent variable in part 2 depends upon what happened in part 1. So the independent variable in part 2 was the previous shock and or control. So once again, Group A had no shock. They had a history of no shock. That was their level for the independent variable. Group B had a history of shock and control. That was their level for that independent variable. And then Group C had a history of shock and no control. So that was varied across each group. And again, that was under the control of the experimenter, hence the independent variable. The dependent variable in this case would have been the hurdle jump. So did the dogs jump over that hurdle? How long did it take them to jump over the hurdle? Did they do it during the shock? Did they do it during the tone? This was all behavior that was allowed to vary freely, and it was behavior that the experimenter would measure, not control, so that makes it the dependent variable. All right, in this experiment, what are the stimuli and the responses? What were the events, any event that could cause behavior for the stimuli? What were the responses, instances of behavior? Once again, if you haven't had a chance, pause the video at this point right now, write down your responses for part 1 and part 2, and we'll take them up in just a moment. All right, so hopefully you've written down your responses. Let's take a look at what the stimuli and responses were for part 1 and part 2. So for part 1, the stimuli, again, these are any events that could potentially cause behavior. So the clear stimuli in part 1 was the shock. So the floor being shocked, that was an event that could cause the occurrence of a behavior. So shock was the stimuli for part 1. And then the response that was measured was the panel press. So many different things could have been occurring, and many different things were occurring in this part of the experiment. Dogs would have been running around, dogs would have been barking, dogs would have been jumping up and down. Those are not the responses or the behaviors that were identified as being important to measure, so they're not considered a response. A response is an instance of a particular behavior, and in this case, it would have been the panel press. For part 2, the stimuli were shock, and also in part 2, and I didn't have this here, the stimuli was also the tone. So the shock could have caused, was an event that could cause a behavior, the hurdle jump. The tone eventually also became an event that could cause a behavior. So in part 2, the shock and tone would have been the main stimuli. And then, as already mentioned, the response would have been the hurdle jump. So again, many different things occurred, many different behaviors occurred, but the response was the event, the behavior that was being recorded, the behavior that was being identified as a response, and in this case, it was the hurdle jump. All right, in this experiment, what are the overt and covert behaviors for part 1 and part 2? So once again, write down your answers, pause the video if you need to, and then we'll get to the answers in just a moment. All right, so what are the overt and covert behaviors? What are the behaviors that were overt that could be observed by somebody other than the person performing the behavior? And what were the covert behaviors that could only be observed by the person performing the behavior, in this case, by the dogs? So the overt behaviors might require a little bit of speculation. The covert behaviors will require complete speculation because, again, they're unobservable. So let's give it our best shot and let's see what we come up with for part 1 and part 2. So in part 1, the overt behaviors, panel press would be one of those because you could see the dogs press that panel. Whimpering might be another one. So when they were getting shocked, they probably didn't like it. So whimpering could be another one. Walking around, barking, biting things in the room. All of these are behaviors that can be observed by somebody other than the person, in this case the dog, performing the behavior. So those would all be examples of overt behaviors. Covert behaviors, however, cannot be observed. So feelings of frustration, feelings of sadness, feelings of anger, these are all possible covert behaviors. And again, we can only speculate in terms of what these dogs were feeling internally. And even though we can observe evidence of frustration, evidence of sadness, so for example, whimpering would be evidence of sadness, you can't actually observe the sadness. You can only observe the behavior. You can infer the sadness as a covert behavior, but again, it's not observable, so it classifies itself as a covert behavior. For part 2, overt behaviors, hurdle jump. For group C, who did not learn to escape the shock, whimpering, barking, orienting towards the speaker when they heard the tone. All of these would be examples of overt behaviors. And once again, speculating for covert behaviors, thoughts and feelings like what's with all the shocking. Maybe that's what was happening with some of the dogs. Again, we cannot directly observe that. It's impossible to observe directly a thought. So that would also be an instance of a covert behavior. All right, in this experiment, what are the appetitive and aversive stimuli for part 1 and part 2? So recall that appetitive and aversive mean very specific things in the psychology of learning. Appetitive stimuli are stimuli that the organisms will seek out, will approach, and that's all that it means. Aversive means stimuli that subjects will avoid, will try to get away from. And again, that's all that it means. So it doesn't mean liking. It doesn't mean that a stimulus is good. It doesn't mean that you have positive or negative feelings towards the stimulus. All it means is appetitive, if you approach the stimulus, if you seek it out. Aversive, if you avoid the stimulus. That's the classification. So again, for part 1 and part 2, try to classify the stimuli that you identified as either aversive or appetitive, and we'll see in a moment what the actual classification is. All right, so hopefully you wrote down your answers. Let's take a look. So for part 1, aversive stimuli, the shock. Clearly the shock was an aversive stimulus, something that was that the dogs avoided, and that clearest evidence for that is from group B. So we know that the shock was an aversive stimulus because group B pressed the panel to avoid the shock. So even though our experiences with shock indicate that we would try to avoid shock, we can't judge that for any other person or any other organism unless we see them trying to avoid that particular stimulus. In this case, group B would press the panel to get away from the shock. Hence, we know that that was an aversive stimulus for them. An appetitive stimulus, in this case, also this would be most evidenced in group B, was the panel. So dogs in the group B would approach the panel. They would stay close to the panel. They would become very attached almost to the panel. They would seek the panel out, meaning that had become an appetitive stimulus. So for most dogs, there's nothing about a panel that is appetitive, but because of the establishing operation of the shock being turned off by the panel, that panel became an appetitive stimulus for group B. All right, and in part 2, the aversive stimuli would be the shock, because again, they actively tried to avoid the shock. In the setup of the room, the aversive stimuli would also include the tone. If you wrote that one down, you're also correct, because if a tone was coming from one side of the room, you would avoid it by jumping to the other side. So that was also something that was being avoided. And the appetitive stimuli would be the hurdle, the other side of the room. Again, these are all things that the dogs would seek out, would get near to, would indicate through their behavior, their seeking out behavior, that it's an appetitive stimulus. All right, in this experiment, what are the temporally contiguous events for part 1 and part 2? So events that occurred close together in time. And what are the spatially contiguous events, part 1 and part 2? Events that occurred close together in space. For spatially contiguous, we're mostly going to focus on part 2 because we actually have a picture of the shuttle box so that we can see what was spatially contiguous. But again, write down your answers, and in a moment we'll see what was the actual case. All right, so hopefully you paused the video if you needed and wrote down the answers. So let's see what's the case for part 1. So for part 1, temporarily contiguous clearly was the panel press and the end of the shock. For group B, when they pressed that panel, the shock ended. So it was immediate. It occurred right after another. You press the panel, shock is over. So that would be temporarily contiguous. And that was one of the factors that enabled these dogs to learn very quickly that the panel press caused the end of the shock. Spatially contiguous, as I mentioned, we don't know. We don't know what the room looked like. We don't have the layout of the room, so we don't know what was spatially contiguous. I would speculate that the panel was probably close to the floor. If that's the case, if the panel was low enough to the floor, the lower it is to the floor, the more spatially contiguous it was. So the floor was being shocked, the panel press occurred. If it occurred close to the floor, that would be spatially contiguous. And in most cases, the higher temporal contiguity you have, the higher spatial contiguity you have, the easier it is to learn that association. All right, part 2, temporally contiguous, the hurdle jump and the end of the shock. So as soon as you jumped that hurdle, the shock was over. So the event of the hurdle jump immediately caused an end to the shock. Those would be temporally contiguous. And spatially contiguous, the hurdle jump and the end of the shock also were occurring in the same place. So literally the same place that you jumped was where the shock ended. So that would be spatially contiguous. And also the tone and the floor, the speaker seemed to be pretty close to the floor. And the closer it was to the floor, the higher the spatial contiguity of learning the association between the speaker and the shock. So once again, in general, we're going to learn some exceptions, but in general, the more temporal contiguity you have and the more spatial contiguity you have, the easier it is to learn associations. All right, and I believe this is the last analysis we're going to do in this experiment. What is the contingency between the shock and behavior for Group A, Group B, and Group C, both for parts 1 and 2. So the contingencies were different for each group in part 1. So for Group A, there was no contingency. So a contingency, once again, is when one event leads to the probable occurrence of another event. And in Group A, there were no events, so there's no contingency. In Group B, however, the panel press caused the probable end of the shock. Now, in this case, it was 100% probability. You press the panel, the shock ends, but that's still a contingency. The panel press caused the end of the shock. And then Group C was also under a contingency. This one was a little bit trickier. So if you haven't figured these ones out yet, try to pause, work it out. But if you have and you've written it down, here we go. Group C was actually under a contingency. And its contingency was when Group B pressed the panel, that caused their end of the shock. So even though they didn't have any control over their contingency, they were still under a contingency because the event of Group B pressing their panel caused the end of their shock. So 3 different contingencies for part 1. However, for part 2, 1 contingency for all the groups. So Group A, Group B, and Group C were all under the contingency that the hurdle jump, that event, caused the end of the shock. So the hurdle jump caused the probable occurrence of the end of the shock. Again, in this case, it's 100% probability, but that was a contingency. And again, the interesting thing was in the part 2, everybody was under the same contingency, but Group C could not learn that particular contingency. Their learning was impaired. All right, finally, in this experiment, what is the functional relationship between the independent variable and the dependent variable? And this is for part 2 only. So what was the functional relationship? Basically, what was the relationship that Seligman found between prior learning and subsequent learning. And what we have, once again, pause the video at this point, write down your answers so you can, again, make sure that you have these terms mastered. But if you've done that already, let's get to the answers here. So for part 2, the contingency, the functional relationship included the fact that no previous learning leads to new learning to avoid the shock. So no previous learning is related to new learning to avoid the shock. Previous learning to avoid a shock leads to new learning to avoid a shock. And previous learning that you cannot avoid shock inhibits new learning to avoid a shock. So that is the functional relationship. Sometimes they can be expressed mathematically. This time it has to be expressed linguistically. But that is the relationship between previous learning and learning to avoid a shock. And that is the functional relationship that Martin Seligman discovered with his work on learned helplessness. All right, so what we're going to do now is we're going to turn our attention to research methods. So in this course, we're going to be reading a lot of different studies that have illuminated our understanding of learning. So today we're going to take a look at some of the basics. What are the recording methods that we use to analyze learning? So rate of response and the cumulative recorder. And then we'll take a look at some of the specifically designed research methods that are often used in learning, because oftentimes, especially in animal studies, you might be dealing with a single subject. In therapy, you're often dealing with a single client. So in this case, we'll take a look at the research method designs that are used to ensure that a treatment is effective or an experimental independent variable is actually causing a change in behavior. All right, so recording methods. One of the biggest aspects of behavior that is measured in learning studies is rate of response. So rate of response is just the frequency with which a response occurs over a certain period of time. So just how many responses occur per given unit of time. So some examples of this: if you're measuring bar presses in a Skinner box with a rat, 12 bar presses per minute would be a rate of response. So that might be the average amount that your rat presses their bar. 12 bar presses a minute, you have the frequency per unit of time. If you're a old-timey newspaper delivery kid, you might deliver 40 newspapers an hour. Newspapers is delivering newspapers is the response. 40 is the frequency. Hour is the period of time. So you got 40 newspapers per hour. If you can eat 15.9 buffalo wings per minute, then you would be in the running to be the chicken wing eating champion here in the United States. So that was what Joey Chestnut actually achieved when he won his championship in the competitive eating annual competition. 191 wings in 12 minutes, but that boils down to 15.9 buffalo wings per minute, and also boils down to his championship victory. So we'll take a look at one last one, which is 4.3 steps per second. And if you can take 4.3 steps per second, you might be Usain Bolt. And that was the rate of response that he did when he won his gold medal in the 2012 Olympics. So scientists analyzed his performance. He did 4.3 steps per second on his way to that gold medal world record making victory. And he took 42 steps in total to go 100 meters, and it took him 9.63 seconds. This is one of the reasons why he is so much faster than a lot of his competitors. Because of his height, he only needs to take 42 steps in order to complete the 100 meters. And if you're wondering where everybody else is in this 100-meter dash, they're all back there because they, on average, need to take 44 steps. So his frequency of steps is much lower, but his rate of response, his steps per second, is again at least at the level or higher than his competitors. So what we're going to do right now is we're going to take a look at the idea of the cumulative recorder. So we were talking about rate of response, and a cumulative recorder is one of the ways of measuring that rate of response, identifying what it is, because it measures the total number of responses over time. So if you measure the total number of responses, you know the time, you can get the rate of response. And a cumulative recorder, when you get skilled at reading them, when you develop your skills at reading them, it displays these rates of behaviors and importantly changes in that rate of behavior in an easily readable graphic depiction of that particular behavior. So let's take a look now at a cumulative recorder recording the behavior of a pigeon. So should be popping up. There we go. All right, so we're going to see a pigeon pecking in a Skinner box, and we're going to see a cumulative recorder that is actually measuring the each instance of that particular peck. All right, so what you're looking at right now, this is a cumulative recorder. Back before computers were widespread, it would literally be a huge ream of paper that would slowly unfurl, and it had a pen that would draw a line on that paper, and every single time that that pigeon pecked, the pen would move up a notch. So you can see those little steps. Those indicate every single time that a pigeon pecked at the Skinner box. So it would unscroll, the paper would unscroll at a constant rate. Each time the pigeon pecked, the marker would move up. Once it got to the top, it would reset and go back down to the bottom and move back up again. But this is a cumulative recorder, and as we're going to see, it can indicate the rate of responses. All right, so once again, every time the pigeon pecks, that cumulative recorder goes up and up and up, measuring its cumulative responses and revealing its rate of behavior. All right, so let's take a look at a particular cumulative recording of, once again, Usain Bolt. We're going to go back to his gold in the Beijing Olympics. And we're going to take a look at how a cumulative recorder would analyze his rate of responses. So the response we're looking for is steps that he's taken. And what would a cumulative recorder look like if we actually had recorders in his shoes relaying its information to a computer in terms of how many steps did he take during his gold medal run? All right, so let's take a look at that run first. Oh, all right. Playback, watch this video on YouTube. All right, let's do that. All right, so I'm going to check this video out on YouTube. So there we have Usain Bolt getting ready for his run, and let's start it up with him putting on his game face. All right, so this is his run. So let's say that we start the cumulative recorder right here when he's getting set in the blocks. And let's go to full screen here and check out his gold medal winning run. All right, so you can actually see it's amazing. He actually pulls up at the end, does his little celebration dances, does his little waves to the crowd, and eventually will make his way back to the locker room. So let's say that we did have a cumulative recorder hooked up to Usain Bolt. What might that look like? So we'll take a look here at what the cumulative recorder would look like, and at the beginning, the cumulative recorder would be a flat line. And a flat line on a cumulative recorder indicates when no responses are being made. So this would be the situation when Usain Bolt was in the starting blocks. So again, the response that we're measuring is steps. That's the only response that this cumulative recorder would be measuring. And if Usain Bolt was taking no steps, if he was in the blocks, again, you're taking no steps while you're in the blocks. As long as he's not taking any steps, that cumulative recorder is flat, indicating no behaviors are occurring. However, pretty soon that cumulative recorder would start going up, and up at a very high rate. And this would be the case where he took off on the race after the starting pistol. So another thing that cumulative recorder graphically represents is the rate of response. So the higher the slope on a cumulative recorder, the faster the rate of response. So this slope here is very tilted, very high, indicating that Usain Bolt is off and running at a very high rate. Steps are now occurring at an extremely high rate. Once the cumulative recorder gets to the top, this is a little bit of a throwback back to the fact that cumulative recorders used to be done on paper. They're now exclusively recorded on computers, but the convention of using this graphical system is still widely in use. Sniffy, for example, will show you Sniffy's behavior on a cumulative recorder. Once it gets to the top, the cumulative recorder resets and just goes down to the bottom. So do not confuse this with any sort of behavior. So it's not that Usain Bolt started walking backwards. It's not that he fell off a cliff or anything like that. This downward line is just the cumulative recorder resetting. So he was running, and he continued unbroken, running. And this is where he's sprinting in his 100-meter dash. All right, so at some point, you can see that the cumulative recorder starts to decrease its slope. This is the point where Usain Bolt started to slow down. So this would indicate a decrease in speed. And that was the point that we mentioned earlier where he actually started to pull up and started to ease up, took his foot off the pedal even before he finished the race. So he might have broken the sound barrier if he kept going at 100%. We'll never know. But the slowing down of Usain Bolt near the end of the race is indicated here in the cumulative recorder by a decrease in the slope of that line. In a cumulative recorder, occasionally you'll see a dash or a slash that goes across the line. This indicates when the organism is reinforced. So in this case, this would be the point where Usain Bolt was reinforced for his run. Specifically, this would be the point where he looked back at his world record. So when he looks at the clock after he's finished and he sees that he's demolished the world record, that would be the point where he gets reinforced. So finishing the race, looking at the new world record, that would be indicated as a reinforcement by that slashed line. Sometimes they're across, sometimes they're up and down, but look for that slashed line that indicates reinforcement. And then there was a burst of speed after that reinforcement. This would be when Usain Bolt was celebrating after his world record victory. So once again, a little bit of excitement, took another sprint, had steps occurring in rapid succession, and that would be indicated again by a high slope on the cumulative recorder. Then all of a sudden, there's another flat line. And this would be where indicating that no steps were being taken. And you might think that Usain Bolt, might have taken a nap. He might have just lied down and done nothing. That might be the case. But the only thing that this tells us is that he was not taking any steps. So what might be happening here? He could be moving about like crazy. He could have been doing his little salsa dance. He could be doing his trademark celebration, with the pointing of the hands. He could be doing tons of things. He could have motion all over himself. But as long as he's not taking steps, if he's just sitting there planted in a stance and doing his little, his pointing celebration, as long as steps aren't being taken, the cumulative recorder will not move. So a flat line on a cumulative recorder doesn't necessarily mean that the organism isn't doing anything, but what it means is it's not doing the behavior that we're measuring. So Usain Bolt at this point was not taking steps, could be doing anything else, but if he's not taking steps, the cumulative recorder would indicate that with a completely flat line. And then all of a sudden we see another increase in steps being taken, and this would be the point where Usain Bolt was kind of just jogging back to the dressing room, maybe jogging to give his fans a hug, and that would be followed in the end there by that flat portion, and this is when he finally made it to the dressing room and sat down, probably received a massage from his physical trainers, and didn't take any more steps. So this cumulative recorder that we see here is a graphical representation. It's literally a picture of what Usain Bolt did on his record-breaking run. And again, when you become skilled at reading a cumulative recorder, as you gain more experience with them, you'll be able to decode, the flat parts as being no responses, the high slopes as being a very rapid rate of response, and the slashes as being reinforcement. All right, so what we're going to do right now is we're going to do a little bit of cumulative recorder practice, and I'm going to give you 4 scenarios, 4 descriptions of behavior, and what I would like you to do is to match the cumulative recording to the descriptions of the behavior. So take a look at the descriptions, take a look at the cumulative recordings, and I want you to try to match the descriptions of the behavior to the cumulative recorder. All right, so there's 4 instances of behavior, 4 cumulative recorders. Which ones go with which? Let's start off with behavior number 1. So we have a naive rat learns to bar press for food. He bar presses for a lot of food. He then gets full and stops. Later he gets hungry again and bar presses for food once again. So that's behavior number 1. Behavior number 2, a student hasn't read any pages from her textbook. 3 days before the exam, she reads 1 chapter. 2 days before the exam, she reads another chapter. The night before the exam, she reads the rest of the textbook. After finishing the exam, she doesn't open the textbook again. Behavior number 3, a child who is afraid of falling is learning to ride a bike. Tentative at first. Once the child learns to ride a bike, he rides every day until he falls down. After he falls, he doesn't get back on the bike. And then finally, behavior number 4, a gamer buys a new video game. She plays it every day until she reaches a level she can't complete. Frustrated, she plays less and less and eventually stops. One day she finds a tip online that allows her to complete the level, and she then plays the game every day until she finishes it. So those are the 4 scenarios. Here are the 4 cumulative recorders. So this is cumulative recording A. Again, increases in the slope indicate an increasing rate of behavior, and the slashes indicate reinforcement. So cumulative recording A, that's cumulative recording B, that's cumulative recorder C, and then that's cumulative recording D. So again, what I'd like you to do is match those 4 recordings to the 4 behaviors. And in each case for the behaviors, I'll give you a hint. I'll tell you what the reinforcer is. So for this one, it's pretty clear. The reinforcement is food. So every time that you see a slash, that indicates that the rat received some food. For behavior number 2, the reinforcement is finishing the exam. So the reinforcement, and we've all felt this, is when you finally close that exam book and hand it in, you're done. That's the reinforcement for behavior number 2. Behavior number 3, riding the bike. The reinforcement is a intrinsic reinforcer, comes from within, and that's the joy that you feel when you ride a bike, just the fun of riding a bike. So you ride a bike, you have fun, that's reinforcement, until you fall down, and then he didn't ride the bike again. And behavior number 4, the reinforcement is playing the video game, getting those achievements. So once again, look for, every time that she plays, she will get reinforced until she cannot pass that particular level. So again, match those 4 behaviors to these 4 cumulative recorders. And again, flat lines indicate no response. Increases in slope indicate an increase in the response rate. And those slashes indicate reinforcement that the person is receiving. So again, cumulative recording A, recording B, recording C, and recording D. So this is going to be your sort of take-home challenge. We'll take these up when we come back to class on Tuesday, but try to match each 4 of them. 2 of them are very similar, so really think about the descriptions to make your distinction between those 2 recorders and behaviors. All right, so the last thing that we're going to do today, we're just going to introduce this idea of single subjects design, and then we'll delve into it a little bit more when I come back. But single subjects designs, they are widely used in the psychology of learning. They are widely used, and one of the reasons why they're important to know as well, in clinical practices. So oftentimes in experimental research on learning, there was a single subject that was studied intensively. So 1 rat, 1 dog, maybe 1 extraordinary individual that you just test over and over and over again. In clinical psychology and therapy, oftentimes you're dealing with a single client, and you have a therapy for them. And the therapy can be considered as your independent variable. You have them before therapy and you have them after therapy. And you want to know, did the therapy, if you see an improvement in behavior, did that therapy change this person's behavior, or was it something else? So that is, as we're going to see, is very difficult to determine if you use the incorrect design. So we're going to start with the incorrect design, and then next class when we meet, I'll go through in more in detail the 2 correct designs that are used for single subject research or treatment. So the incorrect way to do this is the single comparison design, the AB design. And this is where you measure behavior in a baseline condition, and then you compare that to behavior in the treatment condition. So you basically measure behavior pre and post treatment, and you would like to say that if the behavior improves in the post treatment condition, that the treatment was successful. However, as we're going to see, that's not the case, not always the case, and we have to make sure that the treatment is actually successful. So let's take a look at an example of that. So this is the same example as in your textbooks. So on the y-axis here, we have the number of cigarettes smoked. So let's say that you are a clinical psychologist, somebody comes to you, you deal with addiction research, somebody comes to you and they say, you know what, I've been smoking cigarettes, I want to quit, can you help me? So you would tell them, yes, we can. And kind of counterintuitively, the first thing you would need to do is nothing, and just tell them, I need you to record how often you smoke per day. So you would give them maybe a recording device or some sort of technique for them to record. They would go away for a week, and that's the baseline phase. That is that pre-treatment phase where you can see for this individual, this is a graph, this is not a cumulative recorder, but this individual seems to average around 17 to 18 cigarettes per day. So that's the baseline of behavior, and that's their level of behavior that caused them to seek treatment. So that's what you're going to compare your post-treatment behavior to. And in this case, we're hoping that the behavior decreases, right? We're hoping that the behavior, because of the treatment, will go down. So when the client comes back and they're like, okay, this is how much I smoke, and you're like, all right, the baseline phase, phase A, that's finished. What I want you to do right now for the treatment, you might tell them, is go to the bank and withdraw a whole bunch of $5 bills. And every time you smoke, you're going to reach into your pocket and you're going to rip up a $5 bill. That's going to be your treatment. That we're going to see is a contingency. That's a punishment contingency. Oftentimes those are beneficial to stop behavior that you don't want occurring. So let's say that that's a treatment that you give this individual. Every time you smoke, rip up one of your $5 bills, and you're going to do that as your treatment. They go away for a week. They smoke, they rip up $5 bills, they smoke, they rip up $5 bills, and they record how many cigarettes they're smoking. And that's your treatment phase. And as you can see here, the number of cigarettes has gone down. So now they're averaging about 10 cigarettes per day. So it used to be 17, now it's 10. It looks like the treatment is effective. However, there is a flaw in the single comparison design, because since you're dealing with one individual, since you're dealing with a single subject, this decrease in behavior might be due to the treatment being effective, but unfortunately, it might also be due to a number of other factors. So at this point, try to think of something else that could have happened on day 7. Try to think of something else that could have coincided with this individual starting their treatment that might have decreased the amount of cigarettes that they smoke. So take a moment, pause the video if you need to. Try to think of 2 or 3 possible things that could have happened that would decrease the number of cigarettes that this individual smoked. All right, did you come up with a few? So I'll just mention some of the things that came to my mind. And some of them could be probable, some of them are ludicrous, but they're all possible. And they're all possible reasons why the behavior went down in that treatment phase. So things that could have affected this, number 1, the individual might have lost their job. So they might have gotten fired, and they might have need to take a hard look at their finances and said to themselves, I can't afford to smoke that many cigarettes a day, so I'm going to have to cut back because of financial reasons. Number 2, they might have gotten sick. Maybe they were in the hospital for a few of those days, and they just weren't allowed to smoke, in the hospital. Number 3, maybe they started dating someone, and that person does not like smokers. So they decided maybe I'll cut down a little bit on that case. Number 4, maybe their mother surprised them with a visit for the week, and their mom doesn't know that they smoke, and they don't want to get in trouble with their mom, even though they're fully grown adults. That can still happen. That might have occurred. Maybe the smoke shop that they buy their cigarettes at burnt down, and now they have to travel further to get cigarettes. Maybe any number of things could have happened that decreased the amount that they smoked. Maybe they went to their cigarette shop and their particular brand was out of stock, and they just don't like the other brand that they bought. So any number of these variables could have caused this decreased behavior in the treatment phase. So now we have a dilemma, because as a psychologist, as a therapist, you don't know, is my treatment effective? In which case we just keep going with this treatment to help this individual, or was your treatment not effective? And we need to know this, because if your treatment wasn't what causes change form behavior, continuing the treatment is a waste of time. It's not going to be effective for this individual, because as soon as their mom goes back from her vacation, as soon as they find a new job, as soon as their cigarette shop rebuilds, whatever the case, their behavior is going to go back to their original levels. So this is the flawed design, and we need different designs to determine whether or not the treatment was effective. So that's what we're going to be doing next time. We're going to start with a look at reversal designs, which add a secondary component to this simple comparison design. And then we're also going to talk about multiple baseline designs. Those are the 2 major designs that are used for single subject research or single subject treatment. All right, so that is it for today. Hopefully, we'll be seeing you on Tuesday. So again, think about the cumulative recorder, match those up to the behaviors. And when we get back, we'll take those up and we'll take a look at the correct single subject designs that can help you understand whether a treatment was effective or not. All right, so all that next time. All right, thanks for joining me, and we'll see you in class.